Good morning. Today we're going to see the transfer functions of an electrical system that has two loops. The idea is to illustrate the method that we use if we do it by hand, if we derive the transfer function, or also if we use it the automated process. So what we have in here are two loops. You can see in here simple connections, an RC and I element in here. And the objective is to find the transfer function that relates the voltage P sub C to the input. So basically, if we can summarize it to the question, we want to know a relationship that says B sub C in relation, this is your transfer function. And in here, this is the transfer function. This is what our objective would be. Okay. So let me disappear here for a second. And we'll concentrate on this now. What are the steps that we need to do to do this? So why don't we put this here I'll go over here. Or we could say step one. Okay. The step one would be to derive the system equations. Okay, so let's do that. In order to do this, we use Kirchhoff's laws. And the first one would be that we say that the first is that the voltage on the first loop is equal to current I1 times R plus this would be 1 over C times the integral of I1 minus I sub 2 dt, like that, right? That would be for this first loop. We could also write this in terms of the charge, but maybe we will do it in a moment. And this here would be minus 1 over C, and we're doing this loop now, minus because it's going contrary to the positive direction of I2, minus 1 over I2 minus I1 minus I2, and then dt plus this would be in here L times di dt di2 dt, like this. So these are the equations or equations of the system in here. We could write them in terms of the variable q to make to eliminate these integrals in here. So this is dq1 dt times r plus 1 over c times dq1 dt minus dq sub 2 dt equal, like this. Yeah. And this one in here would be minus 1 over c times the integral of q1 dt, q2 dt, and then plus L times d squared q sub 2 dt squared. Yeah. So these are the equations of the system right here. Right there. So that is the step number one. Step number two is going to be to apply the Laplace transform. So why don't we just go here and put it right there. We're going to call it step 2 would be apply the Laplace transform to both equations. Okay. So in here, what we're going to do is we'll say, okay, we need to remember, I'm sorry, here, say remember, what is the concept of this, remember, what is the concept of the Laplace operator? It says that d dt is equal to s. So consequently, if you have dx dt is equal to s times x of s, and if you have d squared x dt squared, this is s squared times x of s, like that. So it's going to replace and convert the differential equation into an algebraic set of equations in the S domain. So those are the step number 1, 2. It would be nice to put the step number 3 in here. Let me just put the line in here so we separate the notes and we don't confuse things. So right there. Very good. We have a space over here, so we're going to see the step number 2 to apply the Laplace transform. So if this is the case, you have that in here, if you apply to the first equation, you say that b of s is equal to, in this case, q1 of s, this times r, plus 1 over c times q1 minus q2. And so that's what this is. And if we apply it to the second equation, you'll have minus 1 over c times q sub 1 of s, q sub 2 of s, like this. Yeah. And then this would be minus dq2 dt. No, that's this one. So we have plus L times d times s squared times q sub 2 of s. Yeah. These are the two equations on which I need to build my transfer function. But you see in here, two equations, two unknowns, because we need to find out that what B sub C is. B sub C is voltage across the capacity is 1 over C times the integral of I1 minus I sub 2. So this is going to be 1 over C times no, we need to do it in the S domain. So let me just erase this part in here. Oops. Yeah. If you apply it in the S domain, you have that B C of S is equal to 1 over C times Q1 of S minus Q2 of S. Yeah, so we continue with the application of the Laplace transform, and we will rewrite the equations in collecting the terms of Q1 and Q2. So if that's the case, we will have that the element is R plus in here you have the already the transform, so 1 over C, and then this is going to be Q1. We are not Q base, but S over here, we're missing an S in there. So this is S times R plus 1 over C times Q1. Yeah. Okay. So and then we have to put Q2 minus, put minus 1 over C times Q sub 2 of S like that. And then this is equal to V of S. The second equation, let me just separate this. The second equation, this one would be minus 1 over C times Q yeah, so this is minus 1 over C times Q1, and on the second one we will put minus 1 over C, no, plus, because multiply, and then plus LS squared, and then Q2. Now we are ready to find Q1 and Q sub 2 using Cramer's rule. So if you do that, we are going to put the two together and put the, so I'm gonna make some notes in here. Solve for P sub Q1 and Q2. Okay, so we can use Cramer's rule and say that Q1 of S is equal to, and you put the determinant on the numerator and the determinant on the denominator. The one in the numerator is put V of S and then 0, and then you put minus 1 over C, and this would be LS squared what was the one on the bottom here? Q2, yeah, 1 over L squared. Let me just write it down correctly because this one is not right. So this one here, it's gotta be 1 over C plus LS squared. And this other one would be minus 1 over C. Oh. SR plus 1 over C. SR plus 1 over C. And then minus 1 over C. And then minus 1 over C. And 1 over C plus LS squared. So if you multiply this and then subtract this, you're going to have 1 over C plus LS squared times B of S, like that. And then on the denominator, you're going to have S times R plus 1 over C and then multiplied by 1 over C times LS squared, and then plus 1 over C squared. Actually, minus that. Yeah. So this is Q1 of S. And then do we need Q2? Yeah, I think we need Q2 also. We need Q sub 2 is going to be equal, again, using this rule. In the case of 2, we put SR plus 1 over C, and then minus 1 over C, and in the 2 you put B of S, and then 0. And then the same denominator is R plus 1 over C, it's 1 over C, and then so LS squared. So you go over here, this is 0, then you have B of S times minus 1 over C, and then on this you're gonna have S times R plus 1 over C multiplied by 1 over C plus 2S squared, no, plus LS squared. Okay, oh no, minus 1 over C squared. Okay, so having now Q1 and Q2, I am able to find out the transfer function that I want, because see, this is where I am. I am interested in finding this output right here. So I'll just write it down in here so as not to confuse things. But in this case, B of C of S is going to be equal, I'll just copy it from here, 1 over C, 1 over C times Q sub 1 of S minus 1 over C times Q sub 2 of X. See, that's the voltage B sub 2. So now let's just plug this into here because that's what we need to do. So the voltage across the capacitor is going to be 1 over C times Q1, which is what? 1 over C plus LS squared, like that, times V of S. And then the denominator here is R plus 1 over C times L over C times L S squared. No, 1 over C, not L over C, times Ls squared minus 1 over C squared. So that's this one. Minus 1 over C times Q2, which is B2V of S, times minus 1 over C. Yeah, right here. So, and then the denominator is going to be a similar thing, SR plus 1 over C times 1 over C minus L SR squared, 1 over C squared. So we need to simplify this. One way is to multiply the C into this, and that would actually simplify things in the denominator. B sub C of S is going to be 1 over C times L times S squared and this one here is just we're gonna use the C in the denominator, B of S like this, and the denominator would be C times R times S plus 1 because we used it there, times 1 over C times L squared Where is Q1? I want to make sure that I copy Q1 correctly. Yeah, we did. Yeah. This is a plus according to my that's this minus 1 over C because I already introduced 1C. So that is the Q sub C, but we need to go here to the other one, which is B of S times minus 1 over C. See? And then this one in here, I have to again go S C times R times S plus 1, and this multiply by 1 over C plus L S squared plus 1 over C. Okay. I think we need to make a small correction here on a sign that we see this one over here is this a minus plus. So this is a plus over here. And I think we have it right there. Okay, so this is a plus. And then we would need, okay, this is gonna go like this. So let's just see if we can finish this. V of S is equal to, a denominator that is going to be, this would be R times S. Because the C gets eliminated when we multiply this. And then you have plus C times R times L times S squared plus 1 over C, right? And then plus LS squared minus 1 over C. This is going to eliminate this. And at the top in here, we're going to hold B of S times 1 over C times L, and I mean plus LS squared, and then minus 1 over C. So that is going to eliminate this too. So this is going to be B of S times LS squared divided by, in here we're gonna have several terms. This CRS, this is in here cubic, right? And so when we simplify here, this would be L, let's just do RS plus CRLS cubic plus L times S squared. Hopefully we are okay here. B of S like this equals to, and then we have L S. One of the S is going to cancel with the denominator, and this would be R plus C times R times L times S squared plus this is going to be L times S. Yeah. So consequently, we could write that B sub C of S divided by B of S is going to be equal to L times S divided by C R L times S squared plus L times S plus R. This is the transfer function that we have derived by hand. So all it rests for us is to do it using the program and doing it in an automated way. So